welcome to this explainer. Okay, picture this. You're calculating a complex shopping discount, or maybe measuring a weirdly shaped plot of land. Or think about building design, or even how your cellular provider calculates your monthly phone data usage. What do all of these have in common? Well, they all rely on a mathematical tool called polynomials. Now, if that word makes your heart race a little bit, take a deep breath. Today, I'm going to be your friendly neighborhood math tutor. We are going to calmly and confidently conquer this topic together, specifically learning how to find what we call their zeros. So relax, and let's jump right in. Imagine a ball being thrown up into the air. It goes up, hits its peak, and arcs back down to hit the ground, right? That arc is a visual pattern. Now, before we even look at a formula, just keep that shape in your head. Okay, now look at the equation that actually draws that arc. P of x equals x squared minus 2x minus 3. Don't stress about the p of x part, just think of it as the machine that draws our curve. What happens if we feed the number 3 into this machine? Let's do the mental math. If every x becomes a 3, well, 3 squared is 9, minus 2 times 3, which is 6, so 9 minus 6 leaves us with 3, and then we subtract the 3 at the end. 3 minus 3 is exactly 0. Keep that 0 in mind. That little magic trick where everything just perfectly vanishes into nothing, that's the secret to our entire lesson today.
Section 1. Anatomy of a polynomial.
Before we go hunting for hidden zeros, let's just build up some confidence by reviewing the basics. Look at this expression, 5x to the 7th power minus 6x to the 5th plus 7x minus 6. Looks kind of intimidating, right? But reading an equation like this is literally just like reading a sentence once you know the vocabulary. We need to find 3 things: the degree, the coefficient of the x to the 5th term, and the constant. Just take a quick second to scan those numbers. Let's see how you did. First up, the degree is 7. Why? Because the degree is simply the highest power of x in the whole equation, and here, x to the power of 7 takes the crown. Next, the coefficient of x to the 5th is negative 6. The coefficient is just the number parked right in front of the variable. And hey, notice I said negative 6. A huge mistake students make in exams is ignoring that minus sign. Always take the negative sign with you. Finally, the constant term is negative 6. The constant is just that lonely number at the very end, with no variable attached to it at all. If you spotted those, you are doing great.
Section 2. The concept of zero.
Now that we're warmed up, let's tackle our main topic. Please don't look at this as some terrifying abstract formula. It's actually a super logical concept. The formal definition says a real number k is said to be a zero of a polynomial p of x if p of k equals 0. Translating that into plain English for us, a zero is just a secret number that when you plug it into all the x spots, perfectly balances the whole equation out to nothing. Visually, going back to that ball we threw, this secret number is the exact spot on the graph where the line finally touches the ground level, 0. This brilliantly shows exactly what we did at the very beginning of this explainer, when we tested our secret number 3 in the equation x squared minus 2x minus 3, the math worked out to exactly 0, right? So 3 is officially a 0 of that polynomial. But look what happens if we guess wrong. If we test the number 2 instead, the math becomes 4 minus 3, which leaves us with negative 3. Negative 3 is obviously not 0, so 2 is not a 0 of this polynomial. See, it's really just a matter of finding that perfect fit.
Section 3. Solving step by step.
We've got the theory down, so let's tackle 3 real textbook examples together. We'll start easy. We are given the linear polynomial p of x equals 2x plus 5, and we are asked to find its 0. Step 1. Set the whole equation to 0. Step 2. We write it out. 2k plus 5 equals 0. We're just using k here to represent our secret number. Step 3, we use basic algebra to solve for k. First, subtract 5 from both sides, which gives us 2k equals negative 5, then divide both sides by 2, and we get k equals negative 5 over 2. That's it! If you plug negative 5 over 2 back into the original equation, it perfectly cancels out to 0. Ready to level up? Here is a medium difficulty quadratic polynomial. We're given the equation p of x equals x squared minus 9 and asked to check if 3 and negative 3 are zeros. Let's test 3 first. 3 squared is 9. 9 minus 9 is 0. Boom, 3 is a 0. Now let's test negative 3. Remember your basics here. A negative times a negative is a positive. So negative 3 squared is also positive 9. 9 minus 9 is 0. So negative 3 is also a 0. This proves a super important rule. Polynomials can absolutely have more than one 0. All right, you're doing fantastic. Now we are going to look at the hardest example from the text, a real multi-step board exam level question. We are given the equation p of x equals x squared minus 4x plus 3, and we're asked to find the zeros by manually testing 4 different values, 0, 1, 2, and 3. Don't let it intimidate you. We are just running our machine 4 times. You've got this.
Let's walk through these calculations sequentially. First, testing 0. 0 squared is 0. Minus 0 plus 3 leaves us with 3. Not a 0. Let's test 1. 1 squared is 1. Minus 4 times 1 is negative 3. Add the 3 at the end, and that equals 0. We found 1. 1 is a 0. Now let's test 2. 2 squared is 4. Minus 4 times 2, which is 8. So 4 minus 8 is negative 4. Plus 3 is negative 1. Nope, not a 0. Finally, let's test 3. 3 squared is 9, minus 4 times 3, which is 12. 9 minus 12 is negative 3. Add that positive 3 at the end, and we hit exactly 0. So our victorious zeros for this equation are 1 and 3. See, you just solved a major textbook problem flawlessly.
Section 4, True or False Challenge.
Since you're doing so well, let's play a quick game of true or false. These questions are designed specifically to point out the most common traps students fall for on board exams. Here is trap number 1. True or false? The degree of the polynomial, square root of 2 times x squared minus 3x plus 1 is the square root of 2. The reality? This is absolutely false. The test makers put that scary square root at the front to totally distract you. Remember our anatomy lesson earlier? The degree is purely the highest power, the exponent attached to the variable. Here, the highest power of x is 2. The square root of 2 is just the coefficient. Don't let those scary numbers fool you.
Let's look at trap number 2. True or false? The coefficient of x squared in 3x cubed minus 4x squared plus 5x plus 7 is 2. Well, let's find the x squared term. There it is, sitting right in the middle. The number attached to it is a 4. But wait, the statement says the coefficient is 2, so the statement is false. But beyond that, the true coefficient isn't just 4, it's negative 4. Under exam pressure, negative signs are literally the first things to get forgotten. Always take the negative sign with you.
Okay, final trap. True or false? The degree of a polynomial is 1 more than the number of terms in it. This is a sneaky theoretical trick question, and the answer is false. In math, length does not equal power. You could have a massive, huge equation with 20 terms, but if the highest exponent is a 3, the degree is just 3. On the flip side, you could have a tiny equation, like just x to the power of 100. It only has one single term, but its degree is 100. A polynomial's degree is purely about its highest exponent. End of story.
Take a look at this. This is a direct image of the textbook page we've been working from today, Exercise 3.1, Section 3.3. I want to show you this to reassure you, because everything we just conquered together, finding zeros, understanding degrees, navigating those tricky true and false traps, came directly from this seemingly intimidating page. You just successfully navigated real, complex textbook math with complete confidence. It's really not so scary when we break it down, is it?
Section 5, your quick cheat sheet. We're wrapping up this explainer, but as your friendly tutor, I am definitely not leaving you hanging without some quick revision notes. Keep these 5 golden rules in mind. Number 1, a 0 isn't a scary concept. It just means finding the secret number k that makes the whole equation equal 0. Number 2, the degree is always the highest power of the variable in the equation. Number 3, a constant term, that lonely number all by itself, technically has a degree of 0. Number 4, and I literally can't stress this enough, always keep the minus sign attached to your coefficients. And number 5, if you need to find the 0 of a simple linear equation, just set it to equal 0 and use basic algebra to isolate the variable.
And finally, I'm going to leave you with this ultimate surprise test trick. If you are ever sitting in an exam staring at a polynomial and you totally freeze up on the algebraic steps, just take the multiple choice options and plug them into the x spots. Test them out mentally exactly like we did at the very beginning. If the math all cancels out and turns to 0, you have found your right answer. No complex algebra required. So next time you look at a building's design or analyze a data trend on your phone, ask yourself, what invisible polynomials are hiding in the architecture of the world around us, and where do they drop to 0? Keep practicing, stay calm, you've totally got this, and I'll see you in the next